Am I right to think that everybody can see the whiteboard?
Yes.
Excellent. Okay, so if I am organized the way as I hope I am, but you'll tell me if that turns out not to be the case. If I'm organized, where we are is deep into Boolean logic. So there we were working among other things, we had built up to working on truth tables, and there is a concept that we need to work with by way of the truth table, specifically the concept of validity. So here's my thinking, and tell me if this works for you. But of equal, if not more importance, is this. Tell me if you have any questions, problems, confusions about the quiz. If you've undertaken it, before you go back into it, let's talk. Because I think that if we can clarify ideas, if we can practice with some skills, when you do go back into the quiz, you will be much more confident. And you will, even more important than the confidence is the skill set, you will be even better at working on the relevant concepts and skills. So, what I'm thinking is we'll do a brief review of what we've been working on since we started Boole, and then we'll move into picking up that concept that I mentioned just a moment ago, needing to work with in the truth table, namely validity, and then we'll move on to what is arguably the sort of bread and butter, at least starting the bread and butter of our work in proofs. So, I said work in proofs, but what is our bread and butter, namely proofs? So we'll start working with the rules that will direct us strategically and tactically through a proof. Okay, so, but before we start the review, is there anybody who has a question, problem, confusion about the quiz that you want to get to? Let's make sure we put it on our to-do list.
Are you referring to quiz 2 or 3?
Good question, Hannah. Either one. So I've got a sheet of paper out. Let me know if there's any that you want to go over from either quiz, and we will certainly do that. In the meantime, okay, so let's make sure that we're clear on our logical operators. So the system that we're, oh, I'm sorry, Hannah, what are you saying?
Oh, any time could we go over number 23 from quiz 2?
Quiz 2, number 23. Yes. Let me take a quick look. Hold on just one second. So, quiz 2, yeah. You said number 23?
Yeah.
Oh, beautiful. Yeah, okay. All right, I pulled it up. I wanted to see which one it was so that I can sort of orient our thinking toward it. All right, so first, as a reminder or review, I'm just going to trot through some concepts and some skills. Stop me, just interrupt, stop me if you have any questions, problems, confusions, okay? We know that we are working in a logical system that consists of simple sentences and connectives. And in fact, the entire system is built out of simple sentences and just 3 connectives. And the symbolic logic notation for these connectives in our version of the system is as follows. We have the tilde, we have the ampersand, and the wedge or lowercase v. So recall that the tilde is the symbolic logic notation for the ordinary English word not and related expressions, right? Like it's not the case or it's false that, right? The ampersand tells us and or both and. And then the lowercase v or the wedge stands for or. The connective names are negation, conjunction, and disjunction. Right? So the way that the connectives work is by joining together or otherwise operating on a sentence. That sentence can be simple or it can be already compound, right? So let's take, for example, the following sentence. I asked you to write about this in the discussion forum. I think it was, the sentence was, not both Romeo and Felix are enrolled in a logic course. And the way that the sentence is translated is going to preserve or not the ordinary English, right? So let's suppose that we're already comfortable with the translation basics. Let's review. And by the way, remember, if you say, no, Mia, I want to work on some translation, tell me. Or we can always come back to it. But I'm going to assume that we're comfortable with some translation basics so that we understand that in this sentence, the role of the negation is to reject the conjunction. And we know that that's the role of the negation because we have the parentheses that bind the conjunction sentence elements together, right? Now, if we want to know the possible scenarios under which this sentence is true, under which this sentence is false, we construct a truth table. And I think that everybody remembers that the function of the negation is to negate or reject or deny the truth value of the sentence that is being negated, rejected, or denied, right? So if some sentence in the universe P is true, not true is false. And if some sentence in the universe P is false, not false is true. And these possible values are what define the negation, right? So the negation needs to operate on a sentence in order for its truth values to be determined. The conjunction demands that both conjuncts be true. In every other case, the conjunction is false. And then lastly, the disjunction, which also was a prompt choice for you to discuss. The demand is much looser. All you need for a disjunction sentence or a sentence governed by a disjunction to be true is for at least one of the disjuncts to be true. The only time that the disjunction is false is when each of or both of the disjuncts are false. Right? So we use these definitions to make sense of sentences like the one that I asked you to discuss when I was asking you about the significance of the parentheses. So before moving on, what's our confidence level? How is everybody doing? Feeling pretty okay? Questions, problems, confusions? So far, so good?
Yeah.
Yeah, I think if I'll start getting more as you go on.
Okay, and Daniel, think about what is prompting you to recall a concept or a skill, and maybe make a mental note. And yes, and then Daniel, yeah. So Berman, thank you, and Daniel, yes, there will be questions. Think about what's prompting your recall, so that you can make a note of it. It may be the case that if it takes a little bit, and then you go, oh yeah, now I remember. That might be an item for you to go back and drill a bit. Okay. All right. So if we take the following and bring them together, we'll work on the truth table for the sentence. It's not the case. Open paren R ampersand F close paren. In other words, we understand what the tilde means. We understand what the conjunction means. We understand that capital R, capital F are simple or atomic sentences, right? And we also understand what makes a conjunction true, what makes a conjunction false, what makes a negation true, what makes a negation false. And finally, we understand what it means to say that a connective or an operator drives or governs a sentence. So the question here is this a negation sentence, or is it an ampersand sentence? Is it a negation sentence or a conjunction sentence? A tilde or an ampersand? It's a negation sentence because the negation is out front of the parentheses, which means that the scope of the negation covers the sentence that's in the parenthetical. In fact, what's in a pair of parentheses will never be the main operator or connective. So we build up to those values as follows. Everybody also remembers that the number of rows or number of lines in a truth table is determined by 2 to the number of atomic sentences or simple sentences. And as a reminder, this layout is the same. It doesn't matter what textbook you pick up. It's a convention. It's how the truth table always gets laid out. So notice, for example, under P and Q respectively in the conjunction and disjunction definitions, P has half true, half false. Q has alternating true, false, and the half true, half false are half of a row totaling 4, or the number of rows totals 4. So what you do is you take the leftmost sentences, and that's going to get however many rows there are, that gets half true, half false. And then the rightmost sentence, however many simple sentences there are, takes alternate TF. So here we've got 2 simple sentences. That means that it's 2 to the power of 2, so 4 rows. So half true, half false, and then the rightmost sentence alternates true, false, true, false. Right, again, this is the convention, this is the standard that appears always. It's just part of our machinery, okay? Now we can start with our values. Remember, since negation or tilde is the main operator, we're going to determine the values of the ampersand first. And we know by definition a conjunction is true when and only when each of the conjuncts is true. In all other cases, the sentence is false. We also know by definition that the negation rejects the values of the sentence that is negated. So since we're saying not conjunction, right, not both, we're going to say it's not the case that true, it's not the case that false, it's not the case that false, it's not the case that false. Right? And remember, once you've determined the values of, let's say, the subconnective or sub-subconnective, depending on how many there are, right? You're done with those. Just like once you've determined the values of the, in this case, subconnective, you get rid of, you don't need any more, the simple sentence values. Right? Now let's talk a little bit about evaluation. How do we classify this sentence? Is this sentence always true? Which is to say, are the values on every row in the column under the main connective all true? Is the sentence logically true or a tautology? No, because it's false on row number 1. The sentence is contingently true. Right? So the sentence is going to be true depending on the row that we're talking about. Right? But we've exhausted all possible permutations. Okay, how is that going? This rings bells. Are we doing pretty well so far? Okay, let's continue our review, right? So we talked about the tautology. We talked about tautological or logical equivalence or truth functional equivalence. And we talked about self-contradictory sentences. Sentences. Actually, just to make this consistent, tautological, truth functional. Let's do this. And then self-contradictory sentences. Any questions about these? All right. We've also got, as we just saw, contingently true sentences. And let's remember that when we're talking about the rows of a truth table, we're talking about exhausting the possibilities, right? So think about it this way. The sentence that we just worked has only 4 possible ways it could come out true or false. That's because given the simple or atomic sentences, there are only 4 possible combinations of truth values. Okay, how are we doing with this? Are we doing pretty well? Does this ring some bells? Excellent. Okay, so continuing on, we can talk about the exercise that you were interested in, Hannah, by way of equivalences. So remember, a really important equivalence is or set of equivalences are the De Morgan's equivalences, which are abbreviated as DM. And the way that we can think about these sentences is in terms of pushing a negation through parentheses or from within parentheses out front. Okay? So we've got, for example, not both P and Q is equivalent to, and I'm just using 4 dots here to notate equivalence, is equivalent to not P or not Q. And notice when the negation is pushed through, in this case, we're going from the negation outside to pushing it through the parentheses. The conjunction becomes a disjunction. Similarly, if we take the 2 negations on either side of the disjunction and we push the negations out to the front of a parenthetical, the disjunction becomes a conjunction, right? So in our ordinary English, the phrase not both is pretty common. The expression either not one or not the other is less common. Similarly, the expression neither is pretty common. Both or not is probably a bit less common. And by the way, the order that I'm writing these left to right is not essential, right? If we've got truth functionally equivalent sentences, then one or the other can go on either side of that equivalent symbol. And let's also remind ourselves of what we meant when we talked about the idea of truth functionality. Truth is a function of simple sentences and the connectives or operators, right, that work on those simple sentences. So go back to our previous whiteboard, right, the not both sentence. We got to the negation, which is a function of the way negation operates on the values of the ampersand of the conjunction. And the conjunction's values are functions of the meaning of the conjunction in relation to the simple sentence values. Okay? So, if we want to look at these equivalences, right, we know that we have the following, and I'll just put off to the right the reference column for P and Q. That way we don't have quite so much stuff underneath the in the actual truth table. So the standard layout: true, true, false, false, true, false, true, false. And since I'm already over here on the right-hand side, I'll just work from right to left. The disjunction is the main operator, so that means we're going to work it last, right? Over here, the negation is the main operator, work that last. Same over down here, the negation in front of the disjunction is the main operator, while the ampersand is the main operator on the right side of the equivalence. The negations here on the either side of the disjunction cover exclusively, respectively, the P, the Q. Same with the negations down below on either side of the ampersand, on either side of the conjunction. And it doesn't matter which values of those you determine first. Again, questions, problems, confusions, or is everything looking familiar? Are you comfortable? Is there anything that you want to talk about?
I'm pretty comfortable.
Okay, thanks, Hannah. Anybody else? Okay, let's do it. Remember, we're going to negate the values of Q. And those Q values are always the same. And what I mean by that is, if Q happens to be the rightmost, from your direction, rightmost, if Q happens to be the rightmost sentence, it is going to take alternately true, false, true, false, true, false, all the way down, however many rows there are. So we get the following: not true is false, not false is true, not true is false, not false is true. We run on over to the negation of the P. Not true, not true, not false, not false. And then lastly, the disjunction. We know the disjunction is false when and only when each of the disjuncts is false. In all other cases, it's true. Now we move on over to the conjunction. We know that the conjunction is true when and only when each of the conjuncts is true. So row 1 over here on the reference columns, right? True, false, false, false. Negation, false, true, true, true. And just so that we're not distracted, right, now we're ready to look on row number 1. Identical values. Row number 2, identical values. Row number 3, identical values. Row number 4, identical values. Okay. You folks are gonna work the second set. Let's go left to right now. Tell me what to write. I'll start us off. P disjunction Q at row number 1 is true. How about row 2?
True.
Would it be false or true?
Yeah, so remember here, the disjunction is true when at least one disjunct is true. So row number 1, row number 2, row number 3, row number 4.
Oh, okay.
Yeah.
I get the wrong one. Sorry.
Good. No, don't apologize, Berman. It's great that you speak up, because if there is confusion, you can go ahead and resolve it. So true, true, row 3.
True.
Row 4.
False.
Beautiful. Negation, not true.
False.
Not true.
False.
Not true.
False.
Not false. Beautiful. All right, here we go. What are we going to put under the negation P column? Tell me what to write. I am merely your scribe.
True.
So so P is true.
Are we still going from the top right one?
Oh, sorry. So we're here at
Okay.
yeah.
Would we be deriving it from the one that's on the left, or what's from the top?
Oh, I see. I'm sorry, Hannah. Yeah. So PQ.
Okay, so negation P would be at.
Yep. So false
And false.
and
And true and true.
beautiful. Now negation Q.
Would be false. And true. And false.
Oh, true.
Good. So now, thank you for chiming in. Don't make Hannah do all the work all by herself.
Yeah, no, I'm understanding it as she's
Yeah.
saying it.
Good. No, this is good. Great. Jump in, Berman. This is fantastic. All right. Is everybody ready? Conjunction. A conjunction is true when and only when each of the conjuncts is
True.
Good. So row 1.
True. No, false.
Right. So false. Conjunction false is false. Row 2.
False.
Row 3.
False.
Beautiful. Row 4.
True.
Beautiful.
Okay. All right. I'm starting to get it.
Now, what do you notice? I'm going to go ahead because I wrote a lot. I've got a lot of markings here, so let me just go ahead and erase all this. Take a look. Do you see that these two sentences are truth table equivalent, truth functionally equivalent? Another bit of language would be tautologically equivalent, which is just to say truth table equivalent. What do you think?
Will that always be the case?
Yeah.
Okay.
Yeah. In fact, in some versions of the system that we're learning, when we're deep in a derivation, De Morgan's equivalences are used to draw an inference from one sentence to the De Morgan substitution, De Morgan equivalent, or De Morgan replacement. They're variously called equivalence, replacement, substitution, right? So this is what the truth table equivalent sentences look like. They have the same values on every row of the truth table in the column under the main connective. If there is no main connective, there's just one connective, it would be in the column under the connective. Okay? All right, so I'm thinking now is a good time, Hannah, to get to what you wanted to talk about. So hold on just 1 second for that second sentence that you had, and I'm going to throw it on the whiteboard. And I'm wondering if it's clear to us that I'm going to put our reference columns off to the left. If it's clear to everybody that our, oh, sorry, I forgot a paren, didn't I? Yeah. So if it's clear to everybody that the negation is the main operator and it's saying no to the disjunction. In other words, this is a not either or neither sentence. So we've got our possible truth values, and what we want to do is get to the ultimate values under this negation. Yeah? Then if we go back to the complete sentence, even though we're lacking part of, we're lacking the left side of the disjunction, it's going to be placeholder sentence, disjunction, negation. So whatever the values under negation are, we want to know what's going to make the main connective disjunction, namely the one that is, right, so X or, right? We're going to want to know what those values are, because that's what's going to help us know which of the possible choices in that exercise will yield a tautology. Does that make sense? Don't be shy about saying it doesn't, but how are we doing? Does that help you with a way forward, Cameron?
Yeah, I have a different answer now.
Okay. So my thinking is, try it when you're ready, and if it still isn't coming out, then you and I should reconvene and try to work through it just step by step. Okay, so are you good with that? Because I want to make sure that we get to
The final truth table I got is true, 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 false. So that goes on the other side of the mystery operand.
Okay. So then the question is, so you're talking about that disjunction is true, 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 false.
Well, you only get one side, and then on the other side of the disjunction, you have to figure out which ones would work.
Right, but I'm just making sure that that's the I'm sorry, I said disjunction. That's the negation.
That's the negation.
Yeah, sorry, I misspoke. Right. So then the question is, knowing what you know about the truth definition for the disjunction and knowing what you know about those values under the negation, it looks like row 4 is really the only question for you. Right? Because that's the
Yes.
only row where good. Okay, you're on it. Okay, so before we finish off with kind of the review and a little bit of practice, let's make sure we remember. Let's see, where did our whiteboards go? Why am I not finding what I want? Okay, well, I'm not going to worry about that now. Let's talk about the truth table for validity, which really just means using a truth table to determine validity. Okay. So you've got everything that you need to generate a truth table that will tell you whether or not an argument that consists of truth functional connectives in one or more of the sentences is valid, right? So let's take the following example. Suppose we have the sentence, neither P nor Q, and let's make that premise 1. And then let's make premise 2 P. And the conclusion not Q. So first, let's look at the determination of the possible truth values. We know that we've got the following layout. We also know that the sentence P in premise 2 is simple, right? There's no connective, there's no operator working on it. So you just take the values of the reference column P's and you apply them, right? Now you're in a great position to work the truth values for each row. Question for you for premise 1, what is the premise 1, what is the main operator? Is it the negation or the disjunction?
Negation.
Nice. So that means that we're going to work this last. We'll work the disjunction first. And we know that a disjunction is false in one and one case only, and that's when each of the disjuncts is false. And then we reject the values under the disjunction. Don't need to do anything to P. There's nothing to do to P, right? So now we get to not Q. Let's just, we know what the values are under Q, true, false, true, false. So we get false, true, false, true. Okay. Now, does everybody remember the definition of a logically correct, aka valid argument? Yes, Mia, we remember it. And what is it? Tell me.
I don't know if this is exactly what you're looking for, but the premises entail the conclusion.
Yeah, you got it. Thank you, Hannah. Now, let me go ahead and talk about it in terms of our truth table. In other words, the conclusion can't be false if the premises are true. So what do? We look at, and let me go ahead and erase some of the stuff that we don't need. And I'll go ahead and I'm going to go ahead and color code this too, just to. Okay, so what do? We look at every row. So row number 1, the conclusion is false, but that's okay because so is premise 1. We don't care about row number 2 because the conclusion's true, and that does not violate the rule, the definition of validity. How about row number 3? False conclusion, but look, so also are premises 1 and 2. What do we think? Since there is no row on which the premises are true while the conclusion is false, the argument is valid. So what a truth table does is it shows us when an argument is valid and when an argument is invalid. What it won't do is tell us how to derive the conclusion of a valid argument. That's a really important point for us to remember. So let me write that down, or at least part of it down, because that's going to help us move to where we want to go next. The truth table shows us whether or not an argument is valid. It does not tell us how to demonstrate validity. For this, right, for this demonstration, we require rules. Oh dear, what just happened? So what I'm trying to write is, oh, that's weird. Sorry, my tablet just went, my tablet just died, the battery died. Hold on. What I'm trying to type here, or sorry, what I was trying to write was, we require rules. So what I'm going to do is this. Hold on. I'm not quite sure how that happened. It's been plugged in the whole time. It shouldn't have gone nutty. Very strange. Okay. Let me get back in there. Consider this our little break. Maybe I didn't have it plugged in properly. Okay. Where's our login? Here it is. All right, I'm almost back. Hello. All right. Let's try this again. So, share content, whiteboard. Oh. So I'm not quite sure. Yeah, I'm having some battery issues. So let me do this instead. Hold on. Almost there. Okay, so I don't remember the exact wording of what I wrote. So let me try again. So a truth table shows us whether or not an argument is valid. It does not demonstrate validity. In other words, it does not tell us how we can derive the conclusion from the premises. Okay, so we require rules. All right, now, hold on just one second. Yeah. So what I'm going to do, because I hope will be fairly seamless, a piggyback off of our truth definitions, is I'm going to work on this should be chapter 11. In other words, we're going to see how the truth definitions that we have learned are the basis of rules that we'll use to derive the conclusion of a valid argument. Okay? But before we get into that in some detail, let's do a little bit more work on the truth table process for determining whether or not an argument is valid. So, is there any argument, any exercise that were working on in the text that you find confusing, that you want to go over? If not, I'll just throw on the screen a couple of arguments, and we'll work a truth table for those arguments so that we can see if each argument is valid. Oh, and by the way, speaking of stuff that you might want to talk about, do what, for example, I know Julianne did, Cameron did, Hannah did. Make notes of anything that troubles you, and then bring it, whether it's to office hours, or if you can't make office hours, outside of office hours, obviously bring it to class as well, right? But bring it to the discussion so that we can work on resolving the confusion, okay? So definitely make note of what's troubling you. Okay, so no exercise that you're dying to go over? Okay. I'm going to put the following. Oh, sorry, no, that's not the one that I want to do. Sorry. Okay, there it is. No, that's not what I want to do. Hold on. Sorry, I had a brain melt. You know this argument we've talked about it a fair amount. Do you remember the candy argument and the moon is made of green cheese, blue cheese argument?
Yeah.
Awesome. So think about P as I have candy in my left hand, and Q is I have candy in my right hand. Or P is the moon is made of blue cheese, and Q is the moon is made of green cheese. Or P is Mitt Romney was the 44th president of the United States. And Q is Barack Obama was the 44th. It doesn't matter which content you put in, right? Remember those arguments. So what do we know? We know that we know that the disjunction is true in the first 3 rows, false in the 4th. I'm just separating them out this way. Where's my little eraser? There you are. Okay. Then we also know that the conclusion, so this is going to be premise 1. This is going to be premise 2. And this is the conclusion, right? We know that Q is a simple sentence. There's no connective working on it. So we're just going to take the reference values for Q and throw them under the conclusion. And now we need to work the values for not P. So P is true, true, false, false. So not P is false, false, true, true. Yeah? Is everybody comfortable with that?
Yes.
We look at the rows on which the conclusion is false, but we see that on each of those rows, at least one of the premises is false. So the argument does not violate the requirement of validity, right? It's not the case that there is a false conclusion, it's not the case that the conclusion is false while the premises are true. You say, yay! Okay. But what we don't know, so we know the argument is valid, but what we don't know is how we're supposed to prove that the conclusion follows from the premises, right? And this is where rules come in, specifically truth functional rules, okay? Let's also, before we move on, take a look at, I'm just going to bring up another Word doc because I want to take a look at an invalid argument, just so that we can see what the difference is in terms of seeing a row on which the conclusion is false or the premises are true. So let's take this. We'll take the same first premise. And then we will affirm one side of the disjunction. And we're claiming that that leads to a denial of the other side of the disjunction. So this is oftentimes what people think follows on the assumption that we've got an exclusive or, when in fact the disjunction, unless you specify, is inclusive, right? It only needs one of the disjuncts to be true in order for the disjunction itself to be true. So we do the same thing. True, 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 false. No operator working on P, so we just bring over the values from the original reference. And then we operate on Q, false, true. Sorry, my drawing's so bad. False, true. Okay. Is there a row on which the conclusion is false while the premises are true? Yup. So this argument fails on row number 1. Now you might say, but Mia, it's fine on the other 3 rows. Doesn't matter. You only need one exception, one counter example. Row number 1 is the counter example. Right? Row number 1 is the row on which you can falsify the conclusion without violating or contradicting the premises. Thoughts? Okay, so before we leave this topic now, here's what we've been covering. We know how to translate from ordinary English into symbolic logic notation using capital letters for simple sentences and the tilde, the ampersand, and the lowercase v or wedge for respectively negations, conjunctions, and disjunctions. We use parentheses to set off or group together a compound sentence, elements, right? And then we know how to determine whether or not a sentence is true or false. We know what the truth definitions are for each of our operators. We know that the negations truth definitions are respectively false and true because the negation rejects or negates the original value. So a sentence that is true when negated, the negation is false. When the sentence that's negated is false, the negated sentence is true. Conjunction demands that each of the conjuncts be true. So the conjunction is true in one case only, and that's when each of the conjuncts is true. Every other iteration, every other permutation comes out false. The disjunction flips. The disjunction is false only when each of the disjuncts is false, or when both the disjuncts are false. In every other case, it's true. You just need one of the disjuncts to be true for the disjunction to be true. So we took those definitions and we applied them to evaluating individual sentences. Is the sentence a tautology? That is it always true? In the column under the operator or main operator, if there are multiple operators. Is the sentence contingent? That is it contingently true? It's true at least once. It's false at least once, right? It could be the case that the contingently true, let me rephrase that. The contingently true sentence is true at least once, right? And then the self-contradictory sentence is the sentence that's false on every row of the truth table in the column under the main connective. We also looked at truth functionally equivalent sentences. That is, sentences that are true on rephrase, sentences that have the same truth value on every row of the truth table in the column under the main connective if there are multiple connectives, right? And then the last animal that we looked at was validity, right? So we just finished looking at how we can use a truth table to determine if an argument is valid or invalid. So this argument here, as we saw, is invalid. Okay, what are we thinking? How are we doing? Are we ready to build a little more? By the way, if you're starting to get a little bit tired, I hear you. I'm going to ask us to do, so hold on just a second. Yeah, so we have everything we need for our second exam, which just covers truth functionality. But I do want us to start building a really important set of concepts for the work that comes next. So remember here we said that we saw that this argument is valid, but the question is, how do we prove it, right? So it's one thing to know the argument is logically correct. It's another thing to prove that it is. So here's what I'd like us to think about. Hold on just a second. Am I gonna, yeah, there we go. Okay. So when we prove the conclusion of a valid argument, we're going to enlist both strategic thinking and tactical thinking. So the way that strategic thinking works is by way of what I'm going to call some structuring assumptions. So take a look, for example, at sentence number 1, P or Q, the first premise. If we know that the argument is valid, but we don't know which world, that is, which row of the truth table obtains, then we're not going to know how that first sentence is true. Does that make sense to say? Right, so if I know that the sentence is true, but I also know that there are, oops, why is that happening? Stop, draw. But I also know that there are 3 ways for this sentence to be true, right? Then one approach that I can take is to say, well, I don't know which condition has been met. I don't know which row of the truth table we're talking about. But what if I go ahead and assume that P is the case? Right? So here's what I'm going to do. Bear with me. Let me go back to, how did I get rid of this? No. Oh yeah, that's right. There we go. Okay. Okay, so bear with me. I've shown you something like this before. So tell me if this rings some bells. So here's premise 1. It reads P or Q. Here's premise 2. It reads, it's not the case that P. And then off to the side, I'm just going to put Q. Because I don't know how long it'll take me to prove it, to get to where I want to go. I'm going to put a line underneath that second premise because that demarcates the inference drawing from the givens. Now what I'm going to do is the following. I don't know how the disjunction is true. So what if I just say, well, let me assume that P is true. What follows from that? Well, a contradiction. Can P and not P be true at the same time? No. So, and I think the symbol that we're using in our version of the system is a hashtag for this assumption yields a contradiction. So that's the contradiction symbol. So this assumption washes out. And that means that from a contradiction, anything follows. So I infer Q. Next, I assume that Q is true. And if I'm saying that Q is true, then I'm saying that Q is true. So notice that in either case, whether I have P or I have Q, I have Q. So I've proven my conclusion. This is one way to do it. Okay. Now, let me just erase this and this. Let's go ahead and change the color back to black. Okay. So line 3 is what's known as an assumptive step. Line 4 is the contradiction between lines 2 and 3. And line 5 is the elimination of that contradiction. That ends the subproof on the first side of the disjunction. And then line 6 begins the second side. Line 7 is a reiteration. And now line 8 brings us back to the main line of the sequence, where we conclude by way of an elimination of either side of the disjunction, the sentence Q. So let's think about what's going on this way. This argument form, which we're going to work on, we're going to practice a lot with it. It's called disjunction elimination. This argument form is a form we use as a rule that is rooted in, based on the truth definitions of the disjunction, right? So, imagine I don't know which way this disjunction is true. It could be true in 3 ways. So what I do is I say, well, let me assume one side is true, what follows? Now let me assume another side is true, what follows? We can also introduce a disjunction. We introduce a disjunction the same way as we did when we were building the truth table. If it's true, remember, if it's true that my dog H, or that guy over there, H is a dog, right? If that sentence is true, H is a dog, then the sentence H or Walter is a dog is true. Do you need to know whether or not Walter's a dog to know that the sentence H or Walter is a dog when you know that the sentence H is a dog is true? Let me make the font bigger here. What do you think? Remember when we were building the truth table and we had some sentence P, as long as P is true, the disjunction is true. What about when P is false? Well, as long as Q is true, the disjunction is true. So once again, we're going to get a rule. This one's called Disjunction Introduction. And this rule, again, is based off the truth table for the disjunction. So think about it this way. I'm going to go back to drawing. Right? If the sentence P is true, it follows, therefore, that P or Q is true. So here's our premise. Sorry about my drawing. You already know it's going to suck because I can't use my trackpad and it forces me to use my right hand. Okay. Right? So there's the inference. Now, here's what you're going to want to notice, and you'll get this as you're working through the text. Each of the rules that we have come in pairs. So we've got a pair of, sorry, let me rephrase that because I don't think that was a really well put sentence. Each of the operators that we have comes with a pair of rules. So we have introduction and we have elimination. Okay? So this is a disjunction introduction. And we'll get the form of the rules soon. I just want to get started on them. Okay. Okay, what about the conjunction? What do you know about a conjunction? A conjunction is true under what circumstances? Oops. Yeah, we'll make it 20. What do you think? When we have a conjunction, you can eliminate one side or the other, or you can think about it as eliminating the conjunction. Why? Because we know that a conjunction is true when and only when each of the conjuncts is true. So if P ampersand Q is true, if P and Q are true, P is true. Oh, here's a further inference using what we just learned a moment ago. If P is true, then P or S is true. What? Okay, next. We know that a conjunction is true when and only when each of the conjuncts is true. So, suppose we have the following two sentences. Stewie is a dog. Walter is a dog. Here, I'll put them on the same line like I did before. So, both Stewie and Walter are dogs. This is our conjunction intro. Right? So, Stewie is a dog. Walter is a dog. Criminy. So, both Stewie and Walter are dogs. Whew! Conjunction intro. Does it make sense that the conjunction elim and the conjunction intro are rules that are based on the truth table? Okay, how are we doing? What do we think? There certainly is more for us to get to, but if I'm not mistaken, and please forgive me, yeah, we're going to keep working on this next week. So given that you're still working on some truth table stuff, getting ready to go back into or take your quiz to begin with, and given that you're going to be writing your truth table or your Boole exam starting sometime this week, I think. Why don't we go ahead and leave off with the sort of loose conversation about the rules for the two Boolean connectives disjunction and conjunction. We'll pick those up next week. We'll also complete our discussion of the connectives by talking about the intro and elim rules for the negation, and we'll also talk more about the important role of a truth functional contradiction. Okay. Questions, problems, confusions before we leave off for this week. Don't forget, I've got office hours as well. I can meet outside of office hours. Is there anything else you're dying to talk about? You're
not at the moment.
You're so excited. You're so overwhelmed with wonder that there's nothing that you're dying to talk about. Is there anything in the quiz that you want to go over before we leave? Are you feeling a little bit more confident about what you're doing? Please don't forget, the more practice you do, the better. I believe I owe you some additional practice, so I apologize that I haven't got on that, but that will be posted. Anything else that you're dying to talk about?
No, but the truth tables we did in class today they help a lot.
Okay, you're feeling a little bit better about that, Hannah? Good.
Yeah.
Okay. Well, if remember, one of the nice things about our quiz setup is that you can keep working on it, and if you run into trouble, let me know and we can chat. And then remember that you want to really make sure you're as skilled as can be, so that when you go to work the exam, you're good to go, because there you're wanting to sort of showcase your skills, because I think it's just the one attempt on the exam. Okay. And yeah, so if you need anything, let me know, stay on the line. Otherwise, I will see you next week.
Thank you.
Thanks, everybody.
Hey, thanks. Bye-bye.
Have a good one.